Now we will prove this formula starting from the first one. The first one is the hardest one to prove. Okay, so I will prove formula 1, which is cosine alpha plus beta equals to cosine alpha cosine beta minus sine alpha sine beta. Okay, that's what we will prove. Now let me erase all of this first. I want you to sketch together with me what I just erased. Okay, I will start with a unit circle, a circle in the coordinate system, a circle in the coordinate system. Let me move it a bit to the left, and it's on. Sorry, not this one. Possibly like this. Maybe I moved that a little bit to the left. Okay, now it's better. Okay, now what we are going to do is, this is a unit circle. So this is 1, 0, this is 0, 1. Now I want to construct two angles. The first angle is angle alpha. So this is angle alpha here. And because this is a unit circle, then the coordinate of this point here must be cosine alpha sine alpha. I wonder if you remember that. We have done it many, many times ago. Are you following me in graphing?
Yes.
Yes.
Okay, good. Now then, we will now do angle beta, negative beta to be more precise. Let me do it like this here. So this is angle negative beta. Because the angle is negative beta, then the coordinate here must be cosine negative beta sine negative beta. Which is equal to cosine negative is cosine positive, and sine negative is negative sine positive. Okay, now, once you are done with that, I would like you to find, using Pythagorean theorem, the distance from between these 2 points here. Yeah, we want to find the length here. Okay, let's call that D, and that must be the square root of the distance there must be the square root of, let's remember, what's the formula? What's the formula, distance formula? Distance formula will be x2 minus x1 squared plus y2 minus y1 squared. Okay, I will tell you the further idea later on, but for now, we will compute this first. Okay, we'll compute this first. Let's say this is my coordinate 2, and this is my coordinate 1. Okay, so the distance equals to the square root of, that's a very long line, x2 use black color, sorry. Square root of x2 minus x1 quantity squared plus y2 minus y1. y2 will be sine alpha minus y1 is negative, so it becomes plus sine beta squared. If I use color to help you, this is my x2, this is my x1, this is y2, and this is y1. Okay, the negative becomes plus because I have negative sine b. Sine b. Now I will develop this formula. So d is equal to square root of cosine squared alpha. I FOIL this part. I will FOIL this, the first square here. Cosine squared alpha minus 2 cosine alpha cosine beta plus cosine squared beta. That's for the first term. When I extend, when I FOIL it. And then plus the second term. Okay, the second term, when I FOIL that, I get sine squared alpha plus 2 sine alpha cosine beta, I'm sorry, sine beta plus sine squared beta. I simplify further. This d is now equals to square root of. Now see what happened if I add these two guys here. What will that be? The cosine squared alpha plus sine squared alpha, what will that be?
Tangent?
No.
Huh?
Cosine squared plus sine squared. That's 1. Okay, so this guy here, when I add them, it becomes this one. Okay, and then I continue. Minus 2 cosine alpha cosine beta. Let me get this one plus 2 sine alpha sine beta. And the last two terms here, when I add them, what do I get?
1.
That's another 1, that's right. Okay, so if I simplify one more step. So if I simplify for this d will be the square root of the first one and the last one. When I add them together, I get 2 minus cosine, 2 cosine alpha cosine beta plus 2 sine alpha sine beta. Okay. Now this is the expression for the length of that segment. We usually call that the chord. The length of the chord from one point on the circle to the other point of the circle. Okay, this yellow chord here. Now, what I am going to do next is, I will rotate this figure. I will rotate this figure counterclockwise by beta. So I will turn it in this direction. Okay, I will turn it in that direction by beta. Now let's see what will that look like. Let me lasso it. I hope I can get a nice picture. Okay, nice. But I don't need this part. 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 Okay. Now I say that I will turn it by beta. I will turn it by beta. Then what will happen is the segment, the radius that originally here will later on becomes here. Okay, I turn it here, and the radius that originally here, I turn by beta, now it becomes here. Okay, let me erase what I don't need. Okay, so basically I turn the original sector earlier, becomes the following sector. Which sector, Thomas? I'm talking about this sector. I was talking about this sector here earlier. Imagine this pizza, I rotate that by angle beta counterclockwise. So now it looks like this. Okay, now expectedly though, because I rotate that, then the distance here should be the same, the length of this chord here. The length of this chord here should be the same to the length of that chord earlier. The one here, the one here, the one here. This chord here should be the same length with the chord here. Okay, now by the way, what is the angle now here? Originally, this was the x-axis, right? You rotate that way. So this is beta, this is alpha, right? So the angle right now is equals to a plus alpha plus beta. Now the distance d here should be the same to that distance that we had earlier, because I rotate the sector by angle beta counterclockwise. So that's what it looks like. Now, of course, the coordinate here is 1, 0. But I wonder if anybody can tell me what's the coordinate here. I give you a hint. I give you a hint. We have learned if the central angle is alpha from positive x-axis, then coordinate will be cosine alpha, sine alpha. I mean, we learned that a long time ago. Okay, I just don't know how much you remember that, but we need to remember that. If the central angle from positive x-axis counterclockwise is alpha, then the coordinate on the unit circle correspond to that angle is cosine alpha, sine alpha. Now, what happens if the angle is alpha plus beta? Then the coordinate here will be cosine alpha plus beta, sine alpha plus beta. Now, from the earlier point of view, this is the length of that chord D. This is the length. Okay, but we now have another way to compute it. This is equals to the square root of, let's say this is my x2, x1, and then y2, y1. Nah. So x2, that's cosine alpha plus beta, minus x1, which is 1, squared plus y2 minus y1 squared. That's my distance formula. Now then, that's equals to the square root of, now notice that this part here, if I FOIL that, it becomes, cosine squared alpha plus beta minus 2 cosine alpha plus beta plus 1. While this part here, well, you subtract by 0. That's basically the same thing. When I square it, it becomes plus sine squared of alpha plus beta. Okay, now notice that this guy plus this guy give you what? This guy plus that guy give you
1.
1, and then I continue minus 2 cosine alpha plus beta plus 1. Go on one more step. We are almost done. So that 1 plus 1 gives me 2 minus 2 cosine alpha plus beta. Okay, so the length of this segment here, is given by this expression, but also given by that expression. Okay, because we know that this line segment here, if you rotate the sector, we get that line segment, right? The sector looks like that. Okay, they're supposed to be the same length. So the blue box, I mean the green box that we have up here should be the same to the yellow box. Okay, now let me write it down. So D equals to the green box first. The green box is square root of 2 minus 2 cosine alpha cosine beta plus 2 sine alpha sine beta. Okay, that's what we have on the green box above. I basically copy paste that down. However, that guy is the same to this yellow box. They're the same. That's the same chord. Now then, using this, then you'll see, oh, when I square both sides, I will get 2 minus 2 cosine alpha cosine beta plus 2 sine alpha sine beta equals to 2 minus 2 cosine alpha plus beta. I will cancel the 2, right? I will cancel the 2 with the 2 here. Okay, I cancel the 2. Now I have negative 2 cosine alpha cosine beta plus 2 sine alpha sine beta equals to negative 2 cosine alpha plus beta. Now, I wonder if you follow me in writing. Okay, nobody say anything. Anyway, I go on. I will divide both sides of the equal sign by negative 2. So I will divide by negative 2. If I divide by -2, then the first term here becomes cosine alpha cosine beta. +2 divided by -2 becomes -1 sine alpha sine beta equals to cosine alpha plus beta, which is basically what we need to prove. Okay, that's what we need to prove. That is cosine alpha plus beta equals to cosine alpha cosine beta minus sine alpha sine beta. I know this one proof here is freaking scary, but don't worry. This is the only proof that is that long. Of these 6, this is the only one that is that long. In fact, compared to other groups, other formulas, this is the formulas that requires the longest proof. Okay, that's group 1, formula 1. We will now next prove 1, 2. That is cosine alpha minus beta equals to cosine alpha cosine beta plus sine alpha sine beta. Now, we will use the formulas that we already had earlier. The proof, we will prove from left-hand side. We get cosine alpha minus beta. Now, we will see this cosine alpha minus beta as cosine alpha plus negative beta. Okay, so basically you will see later on, I will change this beta here, becomes negative beta. Okay, I will change that beta, becomes negative beta. So this is equals to cosine alpha cosine negative beta minus sine alpha sine negative beta. Okay, you see I replace that beta becomes negative beta. But then using negative trig functions, cosine negative is cosine positive. And sine negative is negative sine positive. That's cosine alpha cosine beta plus sine alpha sine beta. That's our right-hand side. That's the end of the proof. Okay, I'm about to prove 1, 3, and on, but before that, let's do some exercise first. How do we use these? How do we use these, Thomas? Let me rename this first. This is 5, 2, and this is examples. 452. Let's say, for example, example 1, I want to compute what is cosine 75 degrees. Now, this cosine 75 degrees, 75 degrees is not a special angle. 75 degrees is not a special angle. However, we now able to compute it by breaking that cosine 75 into cosine, for example, 30 degrees plus 45 degrees. Now then, go on further. I use formula 1, 1. I have, this is my alpha, this is my alpha. Maybe I use color. This is my alpha, this is my beta. Okay, so formula 1, 1 will be cosine alpha times cosine beta minus sine alpha sine beta. Okay, I just apply the formula. That's why you need to memorize that formula. And then I go on, what is cosine 30 degrees?
1/2.
No. Radical 3 over 2. Okay, cosine 45 degrees.
Radical 2 over 2.
Radical 2 over 2 minus sine 30 degrees.
1/2.
1/2. Sine 45 degrees.
Radical 2 over 2.
Radical 2 over 2. Now put them together, I get radical 6 over 4 minus radical 2 over 4, which is square root of 6 minus square root of 2 over 4. Okay, now that's for cosine 75 degrees. Now let me ask you to try example 2. Cosine, how about pi over 12?
You wouldn't simplify it?
Repeat again?
You wouldn't subtract radical 6 over minus radical 2? Or just leave it as is?
The thing is, it will not be a nice number if we subtract them. So I just leave it as exact form like that. Square root of 6 minus square root of 2. Well, square root of 6 minus square root of 2 is not square root of 4. Though. Square root of 6 minus square root of 4, I mean square root of 2 is not square root of 4. Okay, keep that in mind. So I cannot go further.
Thank you.
Okay. Now, how about cosine of pi over 12? This time we work in radian. Now we can see pi over 12 equals to 4 pi over 12 minus 3 pi over 12. You can see it that way. Why? Because pi over 12 is, 4 pi over 12 is pi over 3, and 3 pi over 12 is pi over 4. Okay, so we can see this by rewriting it cosine of pi over 3 minus pi over 4. Now then, let me give you 1 minute. maybe 2 minutes, you can go on the next 2 steps using formula 1, 2. Okay, expand that using formula 1, 2 and compute the value. Okay, maybe you are able to go to the third or even the last step. Okay, you try. Let me give you 2 minutes. So I hope you understand why I insist you to memorize them. Okay, even after today, if you have not memorized them, please memorize them. Okay, very, very necessary. It's cosine pi over 3 times cosine pi over 4 plus sine pi over 3 times sine pi over 4. Now cosine pi over 3 is
1/2.
1/2. How about cosine pi over 4?
Radical 2/2.
Radical 2 over 2 plus
Radical 3/2.
radical 3 over 2 times
Radical 2/2.
2. That gives us radical 2 over 4 plus radical 6 over 4, which is radical 2 plus radical 6 over 4. We will just leave it like that. Okay. Now, furthermore, so I will just use these 2 formulas here. I will just use these 2 formulas, sum, cosine of sum and cosine of difference for now. We proved these 2 already, and apply that into examples. Okay, so the third example is, suppose you want to prove that cosine x minus 3 pi over 2 is equal to negative sine x. Prove that cosine of x minus 3 pi over 2 is equals to negative sine x. And now we go to the proving mode. From left to right, cosine of x minus 3 pi over 2, according to formula 1, 2. I'm sorry, I'm missing something.
Left-hand side?
Left-hand side first, that's right. Minus 1 times as cosine of x minus 3 pi over 2. Now this is cosine x times cosine 3 pi over 2 plus sine x sine 3 pi over 2. Now cosine x stays the same. How about cosine 3 pi over 2? In case you forget,
Maybe.
I can help you with this. Remember that unit circle? If the angle is 3 pi over 2, you go 3 pi over 2. This is 3 pi over 2, right? What is the coordinate here? If this is a unit circle.
Zero.
1.
0, comma,
Negative
negative 1, right? But at the same time, we know this must be equal to cosine 3 pi over 2 sine 3 pi over 2. I wonder if you remember that. The same idea with, let me go back. This guy, you see, if this is alpha, and that circle is unit circle, then the coordinate of this point here must be cosine alpha sine alpha if the angle is alpha. Now go back to our question. If the angle is 3 pi over 2, then the coordinate must be the same to cosine 3 pi over 2 sine 3 pi over 2. Okay, so from there we see that cosine 3 pi over 2 is
0.
And sine 3 pi over 2 is
-1.
-1. This is 0 minus sine x. That's negative sine x. That's our right hand side. That's the end of the graph. Okay, last example before I prove the others. Example 4. Suppose we want to graph on that 2 by 4 diagram, the one that I usually show you. Y equals to, let's say, 4 cosine 2x cosine x plus 4 sine 2x cos sine x. Now notice that I can factor the 4 out, right? I can factor the 4 out, and then I get cosine 2x cosine x. You know what? Let me change something. Instead of plus, make it minus here. Make it minus there. So if I factor the 4 out, I get 4 times cosine 2x cosine x minus sine 2x sine x. Now, of course, if I suddenly show you that question, you will be yelling at me because, Thomas, you only taught us how to graph sine or cosine, but you never taught us how to combine sine and cosine together like this ugly function, right? Okay, but it turns out that once you memorize the formula, notice what happened here. What will this be?
Cosine 2x plus x.
That's cosine 2x plus x. So what we need to graph is actually y equals to 4 cosine 3x, which I believe you know how to graph, right? Which I believe you know how to graph. I mean, we did that last time in the test, and most of you are okay. This is just approximation. So the graph will be approximately, oh, you know what, the center is 0, maximum is 4, minimum is -4. It's 3x for the angle, no phase shift, so this is 0, this is 2 pi over 3, this is pi over 3, this is pi over 6. That will be pi over 2 here, and that's cosine. So it starts from the top to the middle, going down here, going down there. Of course, it has to be curvy though. Okay. So approximately, that's the graph we want. But notice that we won't be able to graph this if we don't know how to combine this guy here becomes this. You see, it's impossible to do. Okay, that's why you have to memorize that formula. Okay, now let's go back to our proofs. We already proved the first two, cosine sum and cosine difference. How do we prove sine sum and from there sine difference? So proof 1, 3, that is sine of sum equals to sine cosine plus cosine sine. The proof will be, again, we will do it from left-hand side. Like what I said earlier, the hardest one is the first one. Okay, that gives us the very, very deep, strong foundation to be able to do summation and therefore subtraction of angles. Now, sine, we know from cofunction formulas, cofunction identity, that says that sine x equals to cosine 90 degrees minus x, right? The cofunction identity. Therefore, we can see this as, let's say this is my angle x here, then this becomes using cofunction identity. As I remember, cofunction is basic identity group number 3, and that's the first one. That's the cofunction identity. Okay, so sine x equals to cosine of 90 degrees minus x. Now, next, I will do some algebra. Inside the parentheses, we will get 90 degrees minus alpha minus beta. Is it right? I distribute the negative. And then I do further grouping. This is cosine of 90 degrees minus alpha minus beta. Now we will use formula 1, 2. What is formula 1, 2? Formula 1, 2 says cosine A minus B equals to cosine A cosine B plus sine A sine B. Where in this case, this is my A, and this is my B. Okay, now then that will be cosine A minus B is cosine A cosine B plus sine A sine B. that will be cosine A cosine B plus sine A sine B. One last step. This is equals to, what is cosine 90 degrees minus alpha?
Zero.
No,
Sine X.
that's sine x. You see, I just touched that cofunction identity. Okay, so this is sine x. Okay, so sine alpha in this case, cosine beta plus what is sine 90 degrees minus alpha? That's cosine alpha sine beta. Okay, so what I did here is actually I apply that cofunction identity again. What happens here, I apply 1, 2. Now, I get the right hand side now. That's the end of the proof. Okay, now I want you to try proving 1, 4. I want you to try proving 1, 4. I give you the idea. We did it before. I want you to do it again. What is 1, 4? Let me write it down. Proof 1, 4. That's sine alpha minus beta equals to sine alpha cosine beta minus cosine alpha sine beta. Now, what do we do? Is actually you apply, replace this b here by negative b. Replace that b by negative b. Okay, replace the b by negative b. And see what happens if you use the formula 1, 3. So I give you the sketch of the proof. That would be sine of alpha plus negative beta. That's how you rewrite it. And then we did that routine in 1, 2, by the way. Okay. And then from here you will use 1, 3. Okay. And then you will use negative angle B4. The basic identity group number 4. Okay, and then I think right after that, you basically get what you need. Okay, together with this and your break, we come back at 8:30. Right now it's 8:17. 3 minutes to do this and 10 minutes break. We come back at 8:30. So I go on with using formula 1, 3. That's sine alpha cosine negative beta plus cosine alpha sine negative beta. And using negative angle formulas, we will get sine alpha, cosine negative beta is cosine beta plus cosine alpha negative sine beta. So you see the technique I used to do the proofing here is actually the same to what we did in 1-2 earlier. When we try to prove cosine alpha minus beta, we basically rewrite that first as alpha plus negative beta. Remember? And then from there, I use formula 1-1. And somewhere toward the end, I do B4. Okay, so very similar to what we did here. Now then, going further, we are done with the first term, sine alpha cosine beta. Now that negative sine beta, I move the negative to the front. Cosine alpha sine beta. That's what we need to prove. Okay. Now, let's do some examples based on what we memorized. I know some of you, or maybe all of you, get kind of like really discouraged. Thomas, oh, too much proofing for today. Don't worry. For the proofing I show you in this 5-2, you don't need to memorize the proofing, but you need to memorize the formulas. Okay? You need to memorize the formulas. Now let's see example what in this case. I think it's example 5. Example 5. Now, I want you to try this sine of 105 degrees. Now, sine 105 degrees can be rewritten as sine of 60 degrees plus 45 degrees. Now, let me give you 2 minutes to compute this. So this is sine 60 degrees cosine 45 degrees plus cosine 60 degrees plus sine 45 degrees. That's radical 3 over 2 times radical 2 over 2 plus 1/2 times radical 2 over 2. That is radical 6 over 4 plus radical 2 over 4. That is radical 6 plus radical 2 all over 4. Okay, now another one. I will example 6. Let me take from question number 34. Question number 34. Graph one cycle of y equals to 2 times sine x cosine pi over 3 minus cosine x sine pi over 3. Now then, this is equals to y equals to 2 times what? If you combine this, it gives us which formula?
Sine x minus pi over 3.
Minus pi over 3, that's right. So then from here we see that the center is 0, the amplitude is 2, so the maximum is 2, the minimum is -2, the period is 2 pi, and the phase shift is pi over 3. Suppose I draw it in a small way here. center is 0, the maximum is 2, the minimum is -2. The phase shift is pi over 3 plus 2 pi, that will be 7 pi over 3. This is 4 pi over 3. This is 5 pi over 6. And the graph is the graph of sine, so it starts from the middle, going up, going down. Oops, too much. Ice. Like that. Okay. That's for number 36. Now, let me do one hard problem. The following is considered a hard problem, but you will see this type of question a lot in my test. Example 7. I will take this from number 36. It says that let cosine of cosine A equals to -5/13, where the A is in quadrant 2. And then sine B is 3/5. The B is in quadrant 1. Now the questions are find sine A minus B. Part A, find sine A minus B. And question B is find cosine A minus B. Yeah, we will answer part C later on. Now, what makes this question here hard is the setup. Okay, it's the setup. Let me do part B first. Sine B is 3/5. B is in quadrant 1. That's the one makes it easier because it is in quadrant 1. So I will draw the triangle. Let's say this is angle B. Okay, let's say that's angle B. Now then sine B is 3/5. So when I put the numbers on the sides on the triangle, the opposite is 3, the hypotenuse is 5. And in this triangle, what is the adjacent?
4.
That's 4. Okay, now from there you will see that yes, sine B is 3/5. How about cosine B?
4/5.
That's 4/5, that's right. Now, the problem with angle A, it is in quadrant 2. The problem is it is in quadrant 2. So I need to get the reference angle first. Okay, I do the reference angle. Therefore, then what happened to cosine A hat?
5/13.
5/13, we just take the positive value. Right? And that's the reason I make it into reference angle so that we can draw the triangle. Okay, that would be 5/13. And then I can draw the triangle. So this is the triangle. This is angle A hat, not A. 5/13 for cosine. So the opposite will be what the opposite be. Nobody remember. Okay, Okay, that's 12. Okay, the Pythagorean triplets. Okay, now then from there you see sine a hat will be 12 over 13. But the A is in quadrant 2. In quadrant 2, sine is positive or negative?
Negative.
No.
Positive.
Positive. Okay, so the sine A is the same value with cosine of the reference angle. Okay, so at this point we have the following. We already have sine A, which is 12 over 30. For sine A, that's given negative 5 over 13. Okay, and then sine B, that's given, that's 3/5. Cosine B, because it's the first quadrant, then it will be also be positive. Okay, now then we can start answering what is sine A minus B. According to the formula, sine A minus B should be sine A cosine B minus cosine A sine B. Now plug in numbers. Now, I don't suggest you to cross simplify. Okay, I don't suggest you, because we already have LCD if you multiply them. So just multiply them first. That's 48 over 65 plus 15 over 65, which will be 63 over 65. Okay, now I want you to try yourself now. How about cosine A minus B? Okay, let me give you 2 minutes for this. Okay, let's write the formula down first. Always write the formula down first. Cosine A, cosine B, plus sine A, sine B. Okay, you have to memorize the formula though. Please do so. Okay, cosine A is negative 5 over 13. Cosine B is 4 over 5. Sine A is 12 over 13. Sine B is 3/5. So I get negative 20 over 65 plus 36 over 65. That is 16 over 65. Okay, some follow-up question. Where, or which quadrant to be more precise, which quadrant does that angle A minus B, or I think I should say is A minus B located? Now, the way we answer that question is we see the behavior when you put them under the function of sine and under the function of cosine. Now, sine of A minus B is positive, right? Cosine A minus B is also positive. Now, which quadrant gives you the sine and cosine positive?
What do you want?
That's quadrant 1. Okay. Now, like what I said earlier, that you don't need to memorize the proof for this 5-2 of these 6 formulas here. You don't need to memorize the proof. However, you need to memorize the formula. You have to memorize the formula. Okay. In fact, I want you to memorize the formula in that order. I need you to memorize the formula in this order. Okay. Now let's prove further the formula number 5 and formula number 6. Formula number 5, 1, 5 proof, 1, 5. That is tangent alpha plus beta equals to tangent alpha plus tangent beta over 1 minus tangent alpha tangent beta. Proof. From left hand side, tangent alpha plus beta can be seen as using basic formula group number 1. Can be seen as sine alpha plus beta over cosine alpha plus beta. Now, I give you 1 minute. I give you 1 minute to rewrite the formula for sine alpha plus beta and cosine alpha plus beta. Okay, go ahead. The top one, we will use formula 1, 3. The top one, I will use formula 1, 3. And the bottom one, I will use formula 1, 1. So on the top, we will have sine alpha cosine beta plus cosine alpha sine beta. At the bottom, I will have cosine alpha cosine beta minus sine alpha sine beta. Now, I want you to realize that we already have a very similar pattern to what we need to prove. We have something plus something on the top, something minus something at the bottom. Okay? Now, one greatest hint, the biggest hint we have is this. This position here, the green position here, should becomes what?
1.
Should becomes 1, right? So to make it 1, to make this green part here becomes 1, what I will do is I will divide by cosine alpha cosine beta. So what I will do is, that gives us a hint, that I will divide the top and the bottom, divide the top and the bottom by cosine alpha cosine beta. Now, let's see. What I'm about to write here is quite long. Because I want to show you what the detail. Okay, so what happened is on the top left, sine alpha cosine beta, I will divide that by cosine alpha cosine beta. And then plus cosine alpha sine beta on the top right will be divided by cosine alpha cosine beta. You see what I mean? So I apply this dividing by cosine alpha cosine beta to every term. Okay. Likewise, I will do that to the denominator. Cosine alpha cosine beta on the bottom left divided by cosine alpha cosine beta minus the bottom right sine alpha sine beta. I'm sorry. Yeah, sine alpha sine beta divided by cosine alpha cosine beta. You copy that down first. Once you're done copying that down, you see what happened on the top left. On the top left, what canceled?
Cosine beta.
So we have only sine alpha over cosine alpha, which is tangent alpha.
Tangent alpha.
Okay, plus the top right becomes
Tangent beta.
Tangent.
tangent beta. How about bottom left?
One.
One. How about bottom right?
You would split them.
Uh-huh. So I will split them. This guy becomes,
Tangent alpha.
and this guy becomes,
Tangent beta.
which if you think about it, that's what we need to prove. That's our right hand side. That's the end of the proof. Okay, that's what we need to prove. Okay, that's what we need to prove. Now let's prove the last one. The last one, which is something I expect you to know how to prove already. You're not supposed to. You are just playing with the notation. Proof 1/6. That is tangent of alpha minus beta equals to tangent alpha minus tangent beta over 1 plus tangent alpha tangent beta. Okay, let me ask you to prove that. Let me give you 3 minutes for that. Okay, let's work it out together. The proof we will do from left-hand side, just like before. Left-hand side, tangent alpha minus beta, that's equals to tangent of alpha plus negative beta. Now we have done this routine twice. This is the third time. And then we use formula 1,5. This is tangent alpha plus tangent negative beta over 1 minus tangent alpha tangent negative beta. And then we use by basic identity group number 4. Tangent negative is negative tangent positive. Tangent alpha plus tangent negative is negative tangent beta. Okay, 1 minus tangent alpha times negative tangent beta. Right, so what I change are actually this part here becomes this, and this part here, the same part actually, becomes this. Okay, then a little cosmetic, but it's necessary. Tangent alpha minus tangent beta over, I pull the negative here to this negative sign, it becomes 1 plus tangent alpha tangent beta. Okay, that's the right hand side we need to prove. So with this said, I already proved those the group 1. What is left to do is doing some exercise. Actually, we can continue with this here. Let's continue with this here. Part C. Can you compute what is tangent A minus B? Tangent A minus B will be, according to formula 1,6, that's tangent A minus tangent B over 1 plus tangent A tangent B. But then you need to go back and tweak that though. From this triangle, we know tangent A hat will be 12 over 5. What will tangent A be? Notice that angle A is in quadrant 2. If tangent A hat is positive 12 over 5, tangent A will be negative 12 over 5 because A is in quadrant 2. Okay, now how about tangent B? Well, B is in quadrant 1, that's quite easy to do. So tangent A will be negative 12 over 5. Tangent B will be 3 over 4. So this will be negative 12 over 5 minus 3 over 4. And then over 1 plus negative 12 over 5 tangent B, which is 3, 4. It's negative 12 over 5 minus 3 over 4. I multiply the bottom first. Over 1 plus, actually 1 minus 1 minus 36 over 20. Now let me multiply by the LCD over LCD, 20 over 20. We will get on the top left, what's that? 20 divided by 5 is
4.
multiplied by negative 12. Negative 48 minus 20 divided by 4.
It's 5,
Multiplied by negative 3 give us negative
15.
Okay. 1 times 20 is 20. 36 over 20 times 20 is 36. We will get negative 63 over negative 16. That's positive 63 over 16. Now we have done earlier that angle A minus B should be in quadrant 1, right? We did that earlier. And as you can confirm here, our tangent of that angle A minus B is also positive because, well, it's supposed to be positive because A minus B is in quadrant 1. Okay. Another thing to say is, since we already have cosine and sine of A minus B, we can do this part C using those results. Tangent A minus B is equal to sine of difference over cosine of difference, which is sine of difference is 63 over 65, big over cosine of difference is 16 over 65, which simplifies to be 63 over 16, as we expected, the same to what we had just earlier, right? You see that they're the same. Okay, that's for tangent sum and tangent difference. Now, I would like you to memorize the formulas in preparation for our 5-3 on Wednesday. On 5-3, we will do, on Wednesday, we will do 5-3 and 5-4. Okay, we will do 5-3 and 5-4 on Wednesday. Now, the formula for, to prove them is a lot easier. It depends on how good you are with your group 1. So this is group 2. Double angle formula. And I need you to memorize it in this order. The first one, the first variation, cosine 2a equals to cosine squared a minus sine squared a. Formula 1, the second variation, cosine 2a is equals to 2 cosine squared a minus 1.
So it could be either or.
Repeat again?
It could be either the A or B.
Yes, it can be A and B. The thing is we'll need all three later on. The third variation is cosine 2a equals to 1 minus 2 sine squared a. So in some case we need B, in other case we need C, in other situation we need A. Okay, that's why I need you to memorize all three variations for the first group. The second group, I'm sorry, not the first group, the first formula with three variations. The second formula is sine 2a is equals to 2 sine a cosine a. No other variation, only one variation. And then the third formula, tangent 2a is equal to 2 tangent a over 1 minus tangent squared a. Okay, I need you to memorize these three formulas, and for the first one with all three variations. I still have some time, so let me prove part of that, not all of them. And they are actually quite easy to prove. I just want to show you how to do it. Okay, proof 1a. Proof 1a. That is cosine 2a equals to cosine squared a minus sine squared a. And you will see I do the same technique for 2, and 2, 3. Now, of course, then you have to memorize them, right? Okay, proof from left-hand side. That's cosine 2a. But this cosine 2a is basically cosine a plus a. Are you with me?
Yes.
So I can proceed with formula 1, replacing the b by a. This is cosine times cosine minus sine times sine, which is basically cosine squared a minus sine squared a. Okay. Now, actually, we can continue to prove 2, 1b. I continue to prove 2, 1b, and it is by substituting that sine squared a. I will substitute this sine squared a by 1 minus cosine squared a. I wonder if you see that. You see what I mean? This is basic formulas group number 2, the first formula, the Pythagorean identity, which when I distribute the negative, I get cosine squared a minus 1 plus cosine squared a. That is 2 cosine squared a minus 1. Okay, now if you are interested in, you can do it yourself. I don't think I will show that anymore on Wednesday. Suppose I want to do formula 2, 1c. Now I will go on from here, okay? But I will change the cosine squared a instead. Okay? And you will see that this is 1 minus 2 sine squared a. Now, the way we prove 2 is very similar. Sine 2a. I give you the sketch of the proof. So I don't follow the standard procedure anymore. I give you the sketch of the proof. Sine 2a can be seen as sine a plus a. And then I use formula 1, 3. Sine a cosine a plus cosine A sine A. But you see these two terms are the same terms, right? So this is basically 2 sine A cosine A. And then formula 2, 3. How about tangent to A? That's the same to tangent A plus A. Using formula 1, 5, we get tangent A plus tangent A over 1 minus tangent A times tangent A. It's times here, which will give us on the top 2 tangent A. At the bottom, we will get 1 minus tangent square A. Okay, now, so on Wednesday, we will continue with 5.3, but I will not prove this anymore. I will not prove group 2 anymore. I need you to memorize group 1 and group 2. Let me say it again. On Wednesday, I need you to memorize group 1 and group 2. For you to memorize group 2, you need to first memorize group 1. Okay? So on Wednesday, we will do problems from 5.3, applying group 2. And then we go on to group 3, half angles formula, which is coming from group 2, actually. Okay? 5.4 will be from group 2. We derived that to get group 3. Okay, see you then. Oh, hold on. Suggested homework, my bad. 5.2, suggested homework. Number 1 to number 7, that's necessary. And then number 15 to 37. And then some proofing. I would like you to do some proofing. Number 49, 51, 50, no, 55 and 57, 51, 55, 57, and I think that's it. Okay, that's for 5.2.
Can you scroll down a little bit?
Repeat again.
Can you scroll down a little bit, please?
Scroll down. Oh, okay. Give me a second. Like this.
Okay.
Mm-hmm.